Hello, this is Devika. Today we are going to study the topic of electrostatic potential and capacitance. Okay, so firstly, you have to know about what is work done because the energy stored as work done here, that is called as electrostatic potential energy. So general formula of work done equal to force into distance. Okay, this is a general formula used for a small distance we are taking. We have to integrate this between these 2 points to get total work done. So work done in a mechanical terms, but in electrostatic term, if we have a 2 point like P and R points, the charge will be there. So the charge will be here to here. You have to move a charge from this point to this point. You have to do some work. So that work is called as electrostatic potential energy. So the work then is diameter change in potential energy from the point that UP minus UR. UP is called as potential energy at the point P, or R is called as potential energy at the point R. Basically, it is between the charges, so that we rate it as electrostatic potential energy. Okay. So for in same case, the potential, what if the charge will be taken from infinity to the point of P means we have to write it a work formula is like this, work done equal to change in potential energy. So work done and energy will be related with this formula. We will study in 11th chapter itself. So we write as UP minus U infinity. The energy at infinity will be 0. It will same at the energy at potential energy at the point P will be UP. Okay. So that it is external force applied to that charges bringing from infinity to that point. That is electrostatic potential energy. Okay. So what is about potential? We are studying about charges in this chapters. The potential means what amount of work done with respect to the particular charges. Work done with respect to the particular charge will be termed as potential. That is called, the term will be called as V. It can also vary between 2 points. We are changing the potential from this point to this point, from R to P. So potential also changing. So Vp minus Vr equal to Up minus Ur. That is called as work done. So work done with respect to the unit charge is called as potential, electrostatic potential. This is a basic formula. Work done may be represented in joules and electron volt. Electric potential can be written as volt only. Okay. So here is a diagram we are given. So we have so many charges. We are taking a charge power to the point of V. We do some external work that is called as electrostatic potential energy. We do some work with respect to the particular charge called as potential. Okay. What is the potential due to a point charge? If we have one charge, so we have some distance. At some distance, we have 1 point. What is the potential to the point of P is? So V is equal to potential to a point charge formula is equal to K Q by R. It is inversely proportional to the distance and directly proportional to the magnitude of the charges. It can be related with a proportionally constant K. So KQ by R is a formula of a potential. What is the work done formula? So work done formula is work done equal to work done by charge is equal to V. So W is equal to V into Q. So the another charge will be multiplied. Work done will be derived between these two terms, right? So the work done formula is K Q1, Q2 by R square. We will study in the next, the coming chapters. So now you remember this. What is the electric potential? This is a topic now. So what is the potential to the point charge formula, which is K Q by R? What's the K value? 1 by 4 pi epsilon. We already knew that. Okay. So the V and E graph, you show that. E formula is potential to a point charge formula for E is K Q by R square. It is obviously proportional to the distance square. Similarly, potential to the point charge formula is K Q by R. It is also inversely proportional. V and R is inversely proportional. So this diagram is used to represent between V and R and E and R. Okay. Yes. Next topic is potential due to the electric dipole. We already know what is dipole. The equal and positive charges separated by some distance, right? So this positive charges, this negative charges will be separated by some distance means. So that is called as electric dipole. Okay. So what is the potential due to the dipole? We derive some of the expressions. So only 5 mark question. So in the previous chapter, we are studying about what is the potential due to a potential electric field due to the dipole at axial point and equatorial point. Here, what is the potential due to the dipole? Positive charge and negative charge, it is separated by some distance at any point. At any point means it makes some angle here. So The same thing will be derived from the first chapter itself. So potential to the point charge V plus Q is equal to KQ by R. Potential to the negative charge will be KQ by R. The Q will be same, but the R value will be different for these two vectors. R1, R2 will be different. So we just find R1, R2 by using binomial theorems, by using this formula through geometry. And we calculate for the value of R1 and R2 from this expression and substitute them. So that we can get the relation of R. So R is the common vector from R1 and R2. So you're deriving R1, R2 in the form of R vector and substitute that. What is the potential due to the dipole? Means it's a formula. P cos theta by R square. Okay, P is called what? Dipole moment. We studied in the first chapter. The dipole moment formula equal to Q into 2A. Okay, so dipole moment direction is always from negative to positive. Okay, so this is the potential to the point dipole at any point. What if axial point? Axial point means the angle theta will be 0, right? So there is no angle will be formed. It will be in the point itself. So the theta is 0 means, so potential to the axial point formula is P by KP by R square. Okay, what if equatorial point? Equatorial point means the theta will be 90. Theta is 90, cos 90 is 0. So that potential will be 0 for equatorial point. It is for it. This formula is for any point. For axial point, it will be Kp by R square. For equatorial point, it will be 0. Okay. Here, there it is. Okay, let's move on to the next topic. So in this video, we are fully studying about the topic in the book itself. It's a quick revision. Okay. So after, for revision purpose, this video is very helpful to you. So what's the potential energy due to the system of charges? Okay. So if you have too many charges means what we have to do is just add all the potential to a single charge. For V1 means this Q by R1, for V2 means the KQ by R2, V3 means KQ by R3. The distance and the charge will be different. We are finding the potential to the individual charge and just added all that value. That is called potential energy due to the multiple charges. Okay. It's similar to that of Coulomb's law and the electric field due to the multiple charges equation itself. Okay. So the next topic is equipotential surfaces. Okay, it's an interesting topic. What is equipotential surfaces? Potential means V. The voltage is same or equal at all the points of the surfaces. That is called as equipotential surface. Okay, so V is constant is called equipotential surfaces. It is some of the shapes. For a positive charge having this much equipotential surfaces. For a the set value, like for a plane vectors, plane things having this much equipotential surfaces, and for a positive and negative charge having this kind of equipotential surfaces, it will be uniform most likely, but it will be the denser of that line will be thicker here and thinner there. Okay. So they are asking the diagram. What's the equipotential due to the uniform electric field means? The uniform electric field means what? The electric field lines will be equal, and the distance between the electric field lines will be equal. That is called uniform electric field. And the electric field always perpendicular to the surfaces. That is very much important. The equipotential surfaces, the electric field is always perpendicular to it. Okay. And they never intersect. It has some of that properties. The electric field lines are perpendicular normal to that every point of the surfaces, and it will be never intersect. Okay, so the work done in moving a charges from one point to another through a equipotential surface will be 0. Work done in a equipotential surface will be 0. So all the points regarding equipotential surfaces. Okay, so you may watch the diagram. It will be asking for 1 mark and 2 mark question. Write the diagram of equipotential surface of point Q or something. Okay, for plus and minus for a dipole. This is a dipole equipotential surfaces. So next topic is what is the relation between the electric field and potential. In the previous chapter, we are studying about the field. Here we are studying about potential. What is the relation? So the relation is E is equal to minus dV by dl. It will be changing with respect to the distance. Okay. So here we are having two surfaces. We are taking the charge from the equipotential surface, electric field in the upward direction. We are taking a charge P point to the A point. Means what will happen? We have to do some work done. So that work done is equal to that potential difference. Okay, between these 2 points. By using that relation, we can conclude that E is equal to minus dV by dl. It will be related with minus of dV by dl or del V by dl. Okay, so E is equal to general formula used as V by d for general formula. D is called distance, V is for potential. For differentiation, if we are giving the function in terms of potential, you have to differentiate with respect to the distance quotient vector so that we can get the electric field value. Okay. Next is potential energy of system of charges. So we have a charges. Until then, we are studying about potential. Now we are going to study about what is the potential energy between the system of charges. So what will happen? The general formula of potential is this. If we have one on the other charge Q1 and Q2, one on Q2 means what will happen? W by Q is equal to V. So W is equal to V into Q. We already have Q1. So another Q is we multiplied with Q2. So the formula will be half Q1 K Q1 Q2 by R. So this is the potential between 2 point charges. Okay. So if we have any two charges, it will be done the sum or done. Until then, it will be not placed like this because it exerts some force on this. So it will exert some ordinate to place at that particular point. This is the potential energy of the system of two charges formula. Okay. What will be a system of charges? Similar like potential. So if we have three charges means there will be a potential. There will be a ordinate between all the two charges. So you have to add all these force. Okay. So here, what is the ordinate in bringing a charge Q2 infinity to that point? Okay. This is the Q3 point. We are taking Q3 charges from infinity to that Q3 point. So what's the ordinate has to be taken means it has to be maintain some potential energy with Q1 charges and Q2 charges. So that the formula will be like this. 1 by 4 pi epsilon. The general formula is Q1 Q2 by R. Here the same thing will be written with the distance and the charge will be different. Okay. So we have to mention what is the ordinate in bringing a charge either Q3 or Q2 or Q1. What is the relation between this is very much important. Okay. So what about the whole energy needed to develop this kind of arrangement means this is a formula. Each two charges producing some maintaining some potential energy between these. So it will be like this, written like this. K Q1 Q2 by R12, Q3 Q2 by R123 and Q1 Q3 by R12. Okay. So the next topic is what is the potential energy in an external field? Okay, what is if we have two charges, two equipotential surfaces, two dipoles in an external field means what is the potential energy? It will be same as the previous one, not like that because there will be some external field is working on that. So what will happen if we have one charge like this means it will be in an electric field. So it will exert some force on that electric field to maintain its position. So it exerts some force on placing in that field itself. So what on Q2 against external field is Q2 into V2 and what say what on Q1, sorry, Q1 is V1 into Q1. It will exert some force and stand on that external field itself. Okay, it is not in a free space. And after that, it will be developing some force between these two. That is called as K Q1 Q2 by R. We are previously studying, So we that is the whole total Woden formula. Q1 V1 plus Q2 V2 plus Q1 Q2 by 4 pi epsilon naught R. Okay. So it is not same as the potential between two charges because it is an external field. It exerts some force on that position vector itself to place at that point. So that general formula used is W is equal to QV here for these 2 point charges. And added to that, we have to add that if you have two charges means the potential energy developed between these two charges too. So that it will be like this. So Q1 V1, Q2 V2 plus Q1 Q2 by R. Okay. Next topic is potential energy of dipole in an external field. What will happen? You already know. If we have a dipole in external field, it will be rotate so that a torque will be produced. We will study in that. We already studied in that first chapter. So what is the work then in rotating that amount of dipole? We have to calculate here. What in general formula is torque into distance. Okay, for torque into theta for rotation. So if you are taking integration of small angle means theta naught to theta 1 tau into d theta. Tau formula is P sin theta. For integrating sin theta, the value is cos theta. So the final ordinate formula is P cos theta 1 and theta. So that dipole itself making an initial angle is the theta naught and the final angle is theta 1. If we have that theta 1 will be 0 and theta 1. Theta naught we take it as a 0 and theta 1 we take it as 90 degree means. So this formula will be minus P dot E. This minus P cos theta. So this is the work done in a dipole and external field formula. Very much important formula. Okay. So what will happen? What they are asking question, what is stable equilibrium happen in the dipole and external field means stable equilibrium means the energy will be lower. So at what angle the energy will be lower? The energy will be negative at some point. That is called as if theta is equal to 0 degree means P cos theta means the value will be minus P. So that is in that condition, the stable equilibrium will be happen because the energy will be lower. It will be stable. If it is unstable means the energy will be higher. At what point? If theta is equal to 180 degree, that cos 180 value is minus 1. So here also another having another minus, the value will be P. It will be a positive value. So it got some energy, it will be unstable. Okay. The point will be much important in this chapter. Okay. Let's move on to the next topic, electrostatics in conductors. Now itself we are studying about statics, that is insulators. Their charges in an insulator and dielectrics. What if that electrostatics in a conductor means that we just I just read about that points. Inside the conductor, there will be no electric field. It will be spread all over the surfaces. So first point. And next is at the surface of the conductor, the electrostatic field will be normal. The charges will be dispersed all over the surface of the conductor and the electrostatic field will be normal to the point charges. Okay, this is the second point. And the third one is the interior of the conductor, there will be no excess charges because it's a closed surface. We already know that in the central part, there will be no charges, all will be distributed all over the surfaces. That being conductor itself, the charge will be run off easily inside the conductors. Okay. And another is the electrostatic potential inside the conductor will be same. The electric field only 0 inside the conductor, but V is constant all over the surface inside the conductors. Okay, so it is same. And next is electric field at the surface of the charged conductor. Only giving a charge to the conductor means what's the electric field formula? That is sigma by epsilon. Have you derived this formula by Gauss law? General formula is flux is E dot del S. Here relating with one, we take one surfaces, we are getting one closed surfaces. So the Gauss law formula is Q by epsilon. The Q value is sigma into del S. So cancelling that value, so E eligible due to the conducting surfaces formula is sigma by epsilon. Next is electrostatic shielding. Electrostatic shielding is nothing but that the electric field inside the cavity will be 0. Outside the cavity, there will be charges. So the inside, there will be no charges flowing through it. It is similar to the principle of that car in a lightning. If you are inside the car during the lightning period, there will be no charge inside it because the car is a metal body. The charges hitting the surface, it will be goes off through the outside the surfaces. It will be protected from electrical influences, outside electrical influences. So because there will be no field inside it, that is called as electrostatic shielding. Okay. So this is all about the conductors in electrostatics. Next is dielectrics and polarization. Okay, we know that dielectrics are non-kinetic material. What is polarization? We have two kind of molecules naturally, polar molecule and non-polar molecule. For example, hydrogen is a non-polar molecule and H2 is a polar molecule. Polar means the positive and negative ions will be separated with some distance. It definitely have some dipole moment. But non-polar molecule, there will be no such arrangement. Okay. So if you are giving supply electric field to the non-polar molecule means it will happen, it will be separated to minus and plus. So there will be some electric field formed because of that magnetic movement. The magnetic movement all are in same direction. So it will form some electric field. So if you are if the polar molecule already separated with the minus and plus value, but even though they are in random direction, there will be no field before applying any external field. After applying an external field, so it will be aligned to the particular position. Some electric field is there. So that electric field formed with the outside electrical influences, that is called as polarization. The polarization formula is this. It is proportional to the electric field and is related with susceptibility. Okay, we will study in the coming chapters. Okay, the polarization is related with electric field applied to the dielectrics. Okay, that polarization, another formula is dipole moment per unit volume. Every magnet have dipole moment with respect to the unit volume. It produces a that term is called as polarization. Okay. Yeah. So next topic is capacitors, finally. Okay. So capacitor means nothing but there will be two plates or two circular plates are separated by some distance. It will be conducting plate, either two cylindrical plates or something. It's separated by some distance. Means there will be a chance of charge storing capability. Because if you are applying potential to the supplied plate means it stores some of the charges in a positive and negative field. Okay. So the Q is proportional to V. So the proportionality constant will be written as capacitance. So two plates are separated by some distance, that is called as capacitance. The storage capacity is related with the ratio Q by V, that is called capacitance. The unit of capacitance is farad. Yeah. Okay. So it's a very important terms in terms of electrical energy. It's simple as like this: two parallel plates separated by some distance. If it is variable means you just write this like this. Okay. So the first formula of capacitance Q by V. Okay. So it have some dielectric strength so that if you are applying some charges to the plate, the positive charge will be stored here, negative charge will be stored here. Inside it, there will be vacuum or a air. So there will be a dielectric medium so that the charge will be not transferred from here to here so that the charge will be stored there. Okay. This is some of the units: microfarad value, nanofarad, and picofarad value. Just to remind all this, what is the numerical value of this value? Okay. What if, in case of geometry, what is the capacitor formula is like this? In the last chapter, we know we have one sheet means what is the electrical to a single sheet formula is equal to sigma to sigma by epsilon, right? Now we have two sheets means we can just add these two values. So 2 sigma by epsilon naught plus 2 sigma by epsilon naught, the answer is uh, sorry, sigma by 2 epsilon naught. Okay. Yeah, we have two plates. So we just add sigma by 2 epsilon. The value will be 2 sigma by 2 epsilon. So the value is sigma by epsilon itself. So this is the alpha due to parallel plate capacitor formula. So sigma value is Q by A. So Q by A epsilon. This is a capacitance value. Okay, inside the connectors only there will be a electric field. Outside the connector there will be no electric field because the electrical direction is outside. It will be cancelled out. For a positive connector, the direction is outside. Negative connector, the direction is inside. It will be cancelled out. For inside the connector itself, it will be a same direction. So I just add all this value in this inside the connector. It had only have a electric field. That is sigma by epsilon naught. The value will be Q by A epsilon naught. I just rewriting this expression with V into ED. Okay, we know the E value. I just multiplying with the D means the formula will be written as this like this. And the C value is Q by V. So we are dividing the value here. So we got epsilon naught by epsilon naught A by D. This is the capacitance formula with respect to the geometry of the conductor, area, and this is the distance between the conductor. Epsilon is the permittivity of the conductor in a free phase. Okay, it is a farad. Okay. That's all about the capacitor formula. Next, what is the effect of dielectric on capacitance? So if you are changing that intensity, that surface charge intensity means the value also changing. So if you are minusing that intensity from the two different charge intensities, we are subtracting this surface charge intensity on the plates, and we got this electric field formula. And added that if you have any other dielectric medium between these parallel plate capacitor, suppose we have glycerin or something, means we have a dielectric constant called K. So that capacitance value will be increased by K if you are having any medium between the plates, and that voltage value, that electric field voltage stored on the capacitor value will be decreased by K, and the capacitance value will be increased by K. The K is called as permittivity of the medium. We are placing in that place of vacuum or a free space. Okay. Yeah. So the next topic is combination of capacitance. We have two capacitance means either we are combining in a series combination or parallel combination. Series combination means if the two capacitors, one end of the capacitor is connected to another end means series combination. The two capacitors are connected hand to hand. Like this means that is called parallel combination. If you have a increase in the storage capacity of the conductors, means we use either of the combination. In series combination, the voltage will be vary because the charge in a series capacitance will be same. So voltage will be vary means we write as V1 by V2. V formula is Q by C. From capacitance formula Q by V, we write it as like this. The capacitance of the capacitors will be changing, but the Q value will be same. So we written as this formula. Capacitance and series formula is 1 by C1 plus 1 by C2. This is the parallel combination total formula. For a series combination total formula. For a parallel combination, the capacitance combination will be like this. It will be connected to, both the ends are connected to each other. So here the voltage will be same because parallel combination, the voltage will be same. So we are just adding Q1 plus Q2 because it have two charges. Okay. So in parallel combination, the current will be dividing into two chambers like Q1 and Q2. The Q1 value is C1 into V and here C2 into V. We're just adding this value, the voltage will be same. So the formula is C1 plus C2 plus C3. So this is the capacitors in parallel combination formula. And the last topic is the energy stored in capacitor. We are spending some energy to store a positive charge and negative charge in the plate itself. Okay, what is the work done will be there. We are deriving by using the general formula is W equal to VQ. So we are changing that voltage and the charges. Okay, so for a small value, we have to integrate to get the whole value from 0 to Q charges will be stored in that plate itself. So 0 to Q, the value is we write it as V formula as Q by C and del Q. We are integrating Q value, so we got Q square by 2. So that what done in a capacitor formula is Q square by 2C. So we may write it as formula as half CV square and half QV. By using this formula, we are just changing the value of Q value. Q is equal to CV. So I just substitute Q square with the C square and V square by 2C means the CC value will be cancelled. I got half CV square value. Similarly, we rearrange this equation with that for the parameters. We got all this value. Okay. So this is all about this syllabus. And the energy stored in capacitors formula, we know. What's the energy stored the conductor with respect to that um, potential energy with respect to the unit volume. Okay, so that the formula is like this. Half epsilon naught E square. Energy density formula is the energy with respect to that unit volume. Formula is half epsilon naught E square. So the volume formula will be written from that expression. We got this value. That is half epsilon naught E square. So that's all about this syllabus. I just completely revised all the topics in that electric potential and capacitance. Hope you enjoy this video. So just revise all that formulas itself. We will solve the problems in the coming lessons. Okay. So thank you so much.